Welcome to SAP Education Series.
Today we are going to discuss about R3 Data Dictionary. R3 Data Dictionary. The R3 Data Dictionary, or DIC for short, is a utility for defining data objects. Using the DIC, you can create and store objects such as tables, structures, and views. To invoke the data dictionary, perform these steps. Log in with your username and password. This screen will come up. Type the transaction code SE11 in command field to initiate data dictionary. This screen is called as Data Dictionary Initial Screen. Here you can find option to create, change and display the data dictionary objects such as database table, views, data type, type group, domain, search help, lock object. Data dictionary. A data dictionary is the centralized and structured source of information for business applications. The elements that make up a data dictionary are known as metadata. Metadata is data that describes other data. For example, a customer order number would be considered operational data and the length of the customer order number field would be considered metadata. The data dictionary allows the user to create, modify or delete data definitions. A data dictionary facilitates the development of platform-independent applications. A data dictionary eliminates the need for a programmer to be concerned about specific storage locations, drive and directory names, etc. This is the block diagram of DDIC in R3 that shows DDIC role in R3 system. Advantages of a data dictionary. Facilitates the development of platform-independent programs. Avoids inconsistencies when defining data types that will later be used in different parts of the application. This helps avoid redundancy and considerably decrease the cost of maintenance. When a type of data is defined in the dictionary, it is available to any program or function module in the application. A change in the definition of a type of data automatically affects all other data or programs that use that data type. The data dictionary is a great source of information for the developer, user. It is a fast and efficient way to answer questions such as which entries exist in a particular table, what the structure of a particular table is, etc. ABAP Dictionary functionality. The ABAP Dictionary is the core of the R3 development system. It contains an extensive amount of information on the SAP system data, and it has a series of tools for the entry and evaluation of this information. The ABAP Dictionary allows data management without redundancy. That is, information need only be entered once to be available throughout the entire system. All changes take immediate effect in all relevant modules. The ABAP Dictionary is actively integrated into all operative components of the R3 system. Basic data dictionary objects. As we have seen data dictionary objects on data dictionary initial screen, they are also shown in this figure. The basic objects for modeling in the ABAP Dictionary are tables, fields, data elements, domains. The structure of a table is comprised of logically related entities, referred to as fields. A field is not an independent object and can only be maintained within the contents of its particular table. Each field is related to a data element, which in turn is related to a domain. Levels of abstraction. Here we can see the relation between data element, domain and table fields. Let's discuss it in details in next slide. When adding a field to a table, a data element must be specified for that field. When defining a data element, a domain must be specified for that data element. Domains, data elements and fields all have attributes. A data element inherits attributes from the specified domain, and a field inherits attributes from the specified data element. Defining these attributes at multiple levels of abstraction make it easier to make system changes. For example, if the output length of a domain is changed, then the output length will also automatically be changed in all data elements that reference that domain. In turn, the field lengths for all table fields that reference those data elements will also be changed. Domains. A domain is at the lowest level among the sub-elements of a table. It defines the data type and its length. Domain defines a value range which describes allowed data values for the fields. A domain is assigned to a data element. All table fields or structure components that use this data element then have the value range defined by the domain. The relationship between the field or component and the domain is thus defined by the data element of the field or component. Domain ensures consistency. Data elements. Data element is semantic description of fields. Data elements describe the role played by a field in a technical context. Fields of same semantic meaning can refer to the same data element. Contains the field's information. Interdependency of ABAP DDIC objects. A field refers to a data element. A data element refers to a domain. Several data elements can refer to the same domain. Individual data elements can be used in many different fields. Tables in DDIC. A table is a two-dimensional matrix that describes a relationship in the database system. A table structure is defined by a number of logically related entities, referred to as fields. Each row in a table contains precisely one data value for each of the fields defined in the table structure. Rows within a table are uniquely identified by a primary key. The primary key is made up of one or more table fields that uniquely identify each table row. A key, and thus a row, may occur only once within a table. Types of tables in R3. In R3 there are three types of tables. Transparent tables, pool tables, cluster tables, internal table. Transparent tables. A transparent table in the dictionary has a one-to-one relationship with a table in the database. Its structure in R3 Data Dictionary corresponds to a single database table. For each transparent table definition in the dictionary, there is one associated table in the database. The database table has the same name, the same number of fields, and the fields have the same names as the R3 table definition. Pool tables. A pool table in R3 has a many-to-one relationship with a table in the database. For one table in the database, there are many tables in the R3 data dictionary. The table in the database has a different name than the tables in the DDIC, it has a different number of fields, and the fields have different names as well. Pool tables are an SAP proprietary construct. Cluster tables. A cluster table is similar to a pool table. It has a many-to-one relationship with a table in the database. Many cluster tables are stored in a single table in the database called a table cluster. Internal table. Internal tables are defined within an ABAP program. They can be based upon a structure defined within the data dictionary or a structure coded within the program itself. Internal tables are program-specific and cannot be accessed using the ABAP Dictionary. Approaches for creating tables. There are two approaches you can use when creating tables. Bottom-up. Top-down. In the bottom-up approach, you create the domains first, then the data elements, and then the table. In the top-down approach, you create the table first, and then create the data elements and domains as you go along. This figure shows the SAP data classes which we're gonna discuss in next slide. SAP data can be logically divided into four categories. Master data, business data that does not change often, such as vendor master record, general ledger account definition. Transaction data, business data that is volatile, such as customer orders or accounting transactions. System data, control data for the SAP system. Configuration, data that does not change often and that customizes the behavior of SAP R3 applications. Technical settings. The technical attributes of a table are normally defined when the table is created and cannot be changed afterwards. Data class. Data class assigns the table to a physical area in the database. Possible values, APPL0, master data, APPL1, transaction data, APPL2. Organization and customizing data, user, customer data, user 1, customer data. Size category determines the space required for a table in the database.
Possible values 0, 1, 2, 3, 4, equates to an expected number of table records.
Buffering type determines whether and how a table is to be buffered. Logging.
Automatic logging of database changes by users for table where row size less than 455. Thanks for watching. For any query please comment. For more tutorials please like and subscribe. In next chapter we will discuss how to create tables in DDIC.